The kind of method that we are using to solve the partial differential equation, the heat equation that is professionally called a finite difference scheme, because we're forming differences of values that sit in finite distances, not infinitesimal distances. Diagrammatically, what we're doing looks like this. We're using the current value of our current position and the current value to its left and the current value to its right to estimate the next value at our current position. There are other ways for doing this. This is the most simple, but obviously it leads to instability. In the previous quiz, we saw that this scheme has a particular issue with this sort of function, a function that oscillates up and down with each step in space. So let's compute what happens with this very function. Assume that this is our initial distribution of temperature. Temperature at time 0, depending on x. Of course, physically speaking, negative temperatures won't make sense, in particular not without a unit of measurement, but now we're doing a little mathematics. Now let's compute what's going to be the next temperature at x equal to 0, the result of the first step. The temperature at time h is the step size, and position 0 will be its former value times 0 and position 0 plus step size times the rate of change. And the rate of change is thermal diffusivity times the second derivative with respect to x, which we estimate 1 over delta x squared, the old temperature to the left minus delta x, plus the old temperature to the right plus delta x, minus 2 times the old temperature at 0. So what's that going to be? The old temperature at position 0 equals 1. Same here. The old temperature to the left equals minus 1, and that to the right is minus 1 as well. This is 1, minus 1, minus 1, minus 2, which makes minus 4. Step size times thermal diffusivity divided by delta x squared.